Hello all, we are learning the Simulink library blocks. Now we will learn about the lookup tables block. So lookup table, we have various lookup tables, and in Simulink library, if you come here in Simulink tab, you will see here one lookup table tab. Inside it, you will find the 9 types of lookup tables. So the 1D lookup table, 2D lookup table, cosine, direct lookup table like interpolation, pre-lookup table, and so many lookup tables are there. So we will study one by one. First question in your mind comes, what is lookup table? So a lookup table is an array of data that maps input values to output values, thereby approximating a mathematical function. Okay. So given a set of input values, a lookup operation retrieves the corresponding output values from the table. If the lookup table does not explicitly define the input values of Simulink, can estimate an output values using the interpolation, extrapolation, and rounding methods. Various methods are there. Okay, so basically a lookup table or LUTs, lookup table also known as LUT, maps to key values. Key values are unique and no values appears more than once. Okay, so lookup table determines the output values based on the existing data. We can either from mathematical equation to find the output values or have a lookup table based on the existing trials. Most of the time lookup table are implemented when it is difficult to form a mathematical equation. Most of the time that it's happened that difficult to implement a mathematical equation, we can implement a lookup table for instead of that. Okay, as we suggest, like that suggested that here we are looking about the 1D lookup table. There is a one-dimensional lookup table contains one a single dimension array for a table data and single dimension array for breakpoint as well. Okay, so here in this example you can see now the example it illustration of one dimensional lookup table approximate that the function y is equal to x cube. I'm trying to implement here y is equal to x cube. Okay, that lookup table has having some range of like x is minus 3 to 3. So in that way, it's here you can see in the table x is minus 3, minus 2, minus 1, 0, 1, 2, 3. Okay, and that y output at minus 3, cube of minus 3 is minus 27. Cube of minus 2 is minus 8. Cube of minus 1 is 1, 0, 0, 1, 1, 8, 2, 8, 3, 27. In that way, it will work. So here is a breakpoint. These dots are noted as a breakpoint. So from library browser, as you see now from Simulink, like lookup tables that I am using this 1D lookup table here, okay, to show this example. For here in a lookup table, okay, we use an array data map input values to output values, approximating a mathematical functions. So here the given input values for Simulink performs a lookup operation to retrieve the corresponding output values from the table. If the lookup table does not define the input values, the block estimates the output values based upon a nearby table values. So here in this example, you can see now if my input is minus 2, so my output will be minus 8. In that way it will work. So here you can see this is my lookup table, okay, which I have used. So here first there are various operations. First here make I use like table and breakpoints. Okay, here I am be choosing explicit value or I can choose even spacing as well. So what is the use of even spacing and all this thing I will let you know. Here if I'm using a even spacing, so what will happen here in this table you can see now. In this table you can see now if I'm using the even spacing, my first point is minus 3 and even spacing is like 1. Like after minus 3 to minus 2 there is space of 1, like difference between that spacing is that thing is known as spacing is here. And here in table data I have given a values of by minus 27, minus 8, minus 1, 0, 1, 8, 27. So if I'm using an even spacing, so I can do in that way. So lookup table is an array of a data that maps into the value output values. Okay. So there are some interpolation method does not support the explicit values. That's explicit values. So here we are not using a even spacing. Instead of that, we are using the explicit values. So explicit values for breakpoint 1, I have already given that -3, -2, -1, 0, 1, 2, 3. Okay, and these are the table values. So if we want to see this, what is the table values and all these things, so I am clicking here, edit that table. So here, once it will open, you are able to see this table is created here. Okay, this is the values. Okay, -3, -2, -1, and 3, and this is the y values, and this is the graph is created for this. Okay, so how it will work, that thing will be shown here. We can do some operations from here as well, like add or delete a source, add a source, what we want, like some insert or something we can do here. Okay, so now here I'm just saying this. If I am giving some values like what are inside the table, suppose I am giving a -3, apply, okay, and see the output in display, it's a 27. It's in a range, yes, it's in a range. Here you can see it's in a range here. Okay, why this I'm able to showing you, because it's in a range for -3. If I am giving a 0, so I'll get output as a 0 only. Okay, according to lookup table value rate. Okay, if I am giving some 2, so what I'll get output 8. Okay, so if it's in a range, so breakpoint value will be shown here. So what happen if it's not in a range? Okay, if it's not in a range, so here I'll be here you can see now in the second graph. Okay, in the second graph, make it little bit down and I'll zoom this. So here you are able to see basically in the second graph. Okay, uh, where in the second table -1.5 is given, so output will be coming like -4.5. Okay, I'll try to give -1.5. Okay, here, and let's see what output we will get. So we are also getting the -4.5, but what is a cube of -1.5? The cube of -1.5 is -3.7 something, but here we are getting -4.5. We can correct this like by changing the interpolation method. We can correct these errors as well. So this is like if I'm coming here in double clicking there, you can see here algorithm. So here the most appropriate values will be given by cubical spin and alkema schemes spin interpolation methods. Okay, if I am selecting this, I am pressing OK. So you can see now what I'll get, it's -3.15. So it is near to -3.75. If I am changing this to the according to another interpolation method in alkene value, so what I'll get it here -3.46. So it is much more near to the -3.7. So it is also having a less error. So we can change the interpolation method with various combination with the extrapolation methods as well. So we can get that values what we want and all this thing. Okay, so uh, in this thing will work in that way. Now the what is interpolation, and if you comes, and interpolation is a process for estimating a values that lies between between known data points, that lies between the known data point. Okay, so interpolation is a process for estimating the values, that lies between the data points. What is the extrapolation? Then the extrapolation is a process for estimating a values that lies beyond the range of data points. So here in this graph you can see I have given an input as an 4, which is the beyond this table. So I'll show you here. If I'm giving here at 46, apply, okay, and run. Oh, 46, no, I have to give 4. Apply, okay. So here you can see if I am running this now, I'm getting error. Why I'm getting an error? because in this setting here, if I am coming here in algorithm, okay, the diagnostic output range will be I have made a error. If I am making this as a none, then I am running, then I get it, the model will be simulated. So here you can see now, here I will be getting value 46 through the like linear method. If I'm changing this method, here I want the output as an 64. 4 cube is 64. So if I am changing like some alkene, okay, method, so what values I'll get here, you can see now it's more or less, it is getting much more error. So in that way we can debug, we can change the interpolation and extrapolation method, and we will reach near to the what output we want. So this is a future lookup. It will look ahead a future, and it will give us a appropriate outputs to the us according to what are the requirements. Okay, so a rounding process is also there. It's approximating a values and altering its digital according to known rules. Okay, so there are various ways we have studied here. An analytical expression is an expensive to the compute, and there are various expression we can do with using of these and all this thing. Okay, so the explicit and interplicit, like explicit and interpolate methods, now you know interpolation methods, you know. Okay, there is one more example I'll show you how the log table will work with this. Okay, here that one the dimensional lookup table I have used. Here I have given some values, and that range for the breakpoint is 1 to 10 with a spacing of 1, and this is set to some setting that linear interpolation method I will be using here. So if I am giving a 1, then my output is a 0 here, you can see. If I am changing this to the 5, okay, if I am changing this to the 5, so what I'll be getting 0.6999. It is approximate to 0.70. So here you can see the log number 1. So output will be the this logarithm outputs we want. If I am changing this to the 2 or 3, okay, 3 I have switched. Okay, apply. Okay, now I am simulating, so you can see it's 0.48, but it is 0.477. So we can consider this as a 0.48 also. If I am giving it to the 9, then you will see what I will get here. So 0.95. Okay, it's correct. If I am giving here to 10, okay, 10. So now you can see I get output as 1. According to logarithm, that all the outputs are correct. What we want, that desired outputs we are getting. So this is basic concept of 1D lookup table. So there are way like why we are using a lookup table. So the important thing, like few of the time we are not able to implement a mathematical equation. Instead of that, we are using a lookup tables. Okay, so that's all about the lookup table, 1D lookup table. Thank you.